So welcome to this latest video 162 Maths, and in this video we'll be going over the AQA AS Maths paper of May 2022, paper 1 section A, which is the pure section. Now as always I'll include a question breakdown so you can see which question refers to which topic on this paper. So let's get straight into this section A of the AQA AS Maths paper of May-June 2022, paper 1. So looking at question 1, it says express as a single logarithm, and we've got log to the base 10(2) minus log to the base 10x. Now as our bases are the same, we can combine these two logarithms into a single logarithm, and just write there as a 10. And what do we do when we've got indices and we take away? Well, we take away the powers when we're dividing, so that's going to be 2 over x, which is our fourth option. Moving on to question 2, it says the graph of the function of y equals cos to the half x for x is between an inclusive of 0 to 360 degrees is one of the graphs shown below. Identify the correct graph. Now with this particular, if I just do a little sketch of cos x, which is here for 0 to 360, this is what the original graph looks like. Now this, in terms of a graph transformation, is a stretch parallel to the y-axis and is going to be stretching outwards. So if I draw a line of wear between 0 and 360, 0 and 180, now that is going to be 0 and that's going to be 360. So it's this that I'm looking for, which, if I scroll down, is my third option. Moving on to question 3, it says find the coefficient of x cubed term in the expansion of 3x plus a half to the power of 4. Now one thing I notice in this particular question is that the x term is written first. So not that it makes a massive difference, but I'm just going to rewrite it. So I've got half plus 3x to the power of 4. And those two things will be exactly the same because the half is still positive, that's in the bracket, and the 3x is still positive. So from this, now depending on how you work with binomial expansions, so to find, because we're really interested in one term of x cubed, then I know that my Pascal's coefficient is going to be 4, 3. I multiply the first term to the power of n minus r, which is going to be 4 take away 3, which is 1. And then I multiply the second term, 3x, to the term of x, the coefficient of x of what I want. Now if I type this into my calculator, a half to the power of 1 and 3 cubed, it will give me my coefficient, which is 54x cubed. But the question's just asking for the coefficient, not the term, so the answer then is 54. Moving on to question 4, it says find all the solutions of the equation of cos squared theta equals 10 sine theta plus 4 for theta is between 0 and 360, giving your answer to the nearest degree and fully justify your answer. Now what we want to do is basically we want to have an equation where we've just got single trig ratios, so either all coses, all sines, or tans. Now there's not much I can do with the sine, but there is something I can do with this cos squared theta. So replacing cos squared theta with 1 minus sine squared theta, you can see by doing that simple substitution, I've eradicated the use of a cos and I'm now using just sines. So then if I get rid of the brackets, I end up with 1 minus sine squared theta equals 10 sine theta plus 4. Hopefully you can spot that this is now slowly starting to look like a quadratic. So if I take all of this over to the side, I end up with sine squared theta plus 10 sine theta plus 3 equals 0. Now I can see straight away that this is definitely not going to factorize, so I'm going to go straight into the calc. So if I let y equals sine theta, then what this then becomes is y squared plus 10y plus 3 equals 0. Now if I then use a calculator to solve, or you can use a quadratic formula, I get an x value of minus 0.3095 and I get an x value of minus 9.6904. Now, as x, also actually that should be y. Now, because obviously I'm going to be using sine theta, so basically sine theta equals minus 0.3095 and sine theta equals minus 9.6904. I just scroll down. This is basically going to have no solutions because obviously it needs to be between minus 1 and 1. And this one will have solutions. So then if I then solve this, I then get an angle of minus 18.03. Then if I use my sine graph, it's going to be there. So the two angles I'm looking for are these two here, and either using cast or using the graph we get an answer of 198 degrees and 342 degrees. So there are our two answers. Moving on to question 5, it says express 3x cubed plus 5x squared minus 27x plus 10 in the form of x minus 2 ax squared plus bx plus c, where a, b and c are integers. So we know that x minus 2 is going to be a factor. So if I just expand this out, so here I've got x minus 2 ax squared plus bx plus c, and expand that out, so I get ax cubed plus bx squared plus cx, and then minus 2ax squared minus 2bx minus 2c. I can then join those two things together, doing a bit of factorising in the process, in which I get b minus 2a x squared plus c minus 2b x minus 2c. Then if I bring back the original equation, so I've got 3x cubed plus 5x squared minus 27x plus 10. I can see from this that a is going to equal 3, b minus 2a equals positive 5. So if a equals 3, I'm going to end up with b minus 6 equals 5, so b equals 11. And if minus 2c equals 10, c is going to equal minus 5. So then substituting those back into this here, I get x minus 2, 3x squared plus 11x minus 5. Then moving on to question 6, it says AB is the diameter of a circle where A is at the point of 1, 4 and B is at the point of 7, minus 2. Find the coordinates of the midpoint of AB. Now the midpoint between A two points is basically x1 plus x2 all divided by 2 and y1 plus y2 divided by 2. So adding the two x ordinates together, so if I just write midpoint of AB is going to be 1 plus 7 divided by 2 and 4 minus 2 divided by 2, which gives me a midpoint coordinate of 4, 1. It then says for 6b, show that the equation of the circle may be written as x squared plus y squared minus 8x minus 2y equals 1. So for this we know that the centre is at 4, 1. So what I need to do is I need to work out the radius. Now the radius is basically the distance of AB divided by 2. So that if I then go on to work out what AB is, remember that the distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared, all square rooted. So using that formula and using the coordinates of AB, I'm going to get the square root of 7 take away 1 squared plus minus 2 minus 4 squared, and that gives me an answer of root 72. So therefore the radius is going to be 3 root 2. Now obviously root 72 is 6 root 2, so their radius is going to be half, so there's my radius. So then using the centre as 4, 1 and the radius of 3, root 2, I can then work out the equation of the circle, which is going to be x minus 4 squared plus y minus 1 squared equals, and then it's 3 root 2 all squared. So if I then go on to expand all of this out, so I get x squared minus 8x plus 16 plus y squared minus 2y plus 1 equals, and that's going to be 9 root 4, which is 9 times 2, which is 18. And then just chuck the 16 and the 1 over to the other side and end up with x squared plus y squared minus 8x minus 2y equals 1, which is what they wanted me to show. Then moving on to question 6c, it says the circle has a centre C and crosses the x-axis at points D and E. Find the exact area of the triangle. So for us to find where D, E are, so it crosses the x-axis when y equals 0. So if I substitute y equals 0 into the equation of the circle, we then get x squared minus 8x equals 1. Don't know what I'm trying to write there, so let's just change that for a 1. So again, all I've done there is subbed y equals 0 into the equation of the circle. Then solving this, what we end up with is x squared minus 8x minus 1 equals 0. That can't be solved with factorising, so if we then use calc to solve, in which I get two x answers of x plus root 17 and x equals 4 minus 17. So that if I just do a little horizontal line, here is my point of C. Then at this particular point, that's the lowest x ordinate, so that's going to be 4 minus root 17. And this point here is going to be 4 plus root 17. And it's this triangle that I'm wanting to work out the area of. Now, the point C is at 4, 1, which basically means that the distance from the x-axis to point C is going to be 1. So the height of that triangle is 1. So then to work out the base of that triangle, and this is the height, so then the base is going to be the difference between these two numbers. So it's going to be 4 plus root 17 minus 4 minus root 17, and which if I type that into my calculator, I get an answer of 2 root 17. So that means that the area of the triangle using base times height divided by 2 is going to be 2 root 17 multiplied by 1 divided by 2, which gives me an exact answer of root 17, and that's in square units. Then moving on to question 7, it says that a curve has the equation of y equals a squared minus x squared, where a is greater than 0. The area between the curve and the x-axis is 36 units. Find the value of a, fully justify your answer. So looking at the shape of this graph, now we know that a is just a number, but we know that it's a positive number. So if we do an attempted sketch at this graph, so we know that it's going to be a negative parabola, and we know that it's going to intercept at minus a squared. So that's what this, positive a squared. Now, in terms of working out these particular values, now we should be able to spot that this is a difference of two squares. So if I wrote y equals a squared minus x squared, then I can rewrite that as a minus x and a plus x. Now that means that the solutions to this, so if I make that equal to 0, that x is going to equal a or minus a. So this point here is minus a, and this point here is going to be positive a. Now we know that the equation of the curve is y equals a squared minus x squared. So then to find the area enclosed by that, what I then need to do is to integrate a squared minus x squared between these two limits of a and minus a dx. Now it tells me in the question that this is going to be equal to 36. So basically what I can write is this. So then using this, if I integrate that, what I end up with is, well, a squared is just a number, remember, so that's going to be x a squared minus, and it's going to be x cubed over 3, and the limits are a and minus a, and that's equal to 36. Now bear with me, what we now need to do is substitute the values in. So what we get is swapping x with a, so I'm going to end up with a dot a squared minus a cubed over 3, and then minus, and it's going to be minus a dot a squared minus a cubed over 3. So then, and that all equals 36. So then neatening all of this up, I get a cubed minus a cubed over 3 minus, and then that's going to be, well, let's just write this out how it is. So then expanding all of this out, and then if I just neaten this up, I get a cubed minus a cubed over 3, and it's going to be plus a cubed minus a cubed over 3 equals 36. Now I can see that I'm running out of space, so let me just take this over to this side so I can just neaten it all up. So here what I end up with is 2a cubed minus 2 lots of a cubed over 3 equals 36. Then if I take the, well, if I multiply everything by 3, I'm going to end up with 6a cubed minus 2a cubed equals 36 times 3, which is 108. So then 4a cubed equals 108. So a cubed is going to equal 27. So a equals 3, and there is my final answer for A. So then moving on to question 8, it says the curve has the equation of y equals x cubed minus 6x plus 9 over x. Shows that the x coordinates of the stationary point of the curve satisfy the equation of x to the power 4 minus 2x squared minus 3 equals 0. So first things first, let's start by rewriting this equation using indices. So we've got y equals x cubed minus 6x plus 9x to the minus 1. So I can then work out what dy over dx is going to be by moving the power to the front, lower the power by 1. So that becomes 3x squared minus 6 minus 9x to the minus 2. So then from this, we know that at stationary points, dy over dx equals 0. So then what we then get is 3x squared minus 6 minus, and if I write this as 9 over x squared equals 0, I can then multiply everything by x squared, in which I get 3. Let me just start by writing that. So if I multiply everything by x squared, to get rid of that fraction there, so I then end up with 3x to the power of 4 minus 6x squared minus 9 equals 0. I can then divide everything by 3, in which I end up with 4x to the power of 4 minus 2x squared minus 3 equals 0, which is what they wanted me to show. Then moving on to 8b, it says deduce that the curve has exactly 2 stationary points. So if we start by letting y equals x squared, then what I end up with is x to the power of 4 minus 2x squared minus 3 equals 0 then becomes y squared minus 2y minus 3 equals 0. Then from this I can factorise this, so y minus 3 y plus 1 equals 0, so y equals 3 or minus 1. Now if I then replace the x squared back in, so therefore x squared equals 3 or x squared equals minus 1. Now for this there's no solutions. However, for this we've got x equals plus or minus root 3, and that has two solutions, which is minus root 3 and plus root 3. So then our two coordinates, not that he asked for it, is going to be root 3 0 and minus root 3 0. Now moving on to 8c, it says find the coordinates of and the nature of the two stationary points and fully justify your answer. Well, I'm laughing only because we've got our coordinates already, so I did it in the previous question. So when x equals root 3, y equals 0, when x equals minus root 3, y equals 0. So our two coordinates are minus root 3 0 and root 3 0. So that's one part done. So the next thing we then need to do is find the stationary points. So if I then first of all work out what dy over dx is going to be, so that's going to be of, well, let's first of all write out y. So y equals x cubed minus 9x plus 9x to the minus 1. So then dy over dx is going to equal 3x squared minus 6 minus 9x to the minus 2. The second derivative of that is therefore going to be 6x, and it's going to be plus 18x to the minus 3. Now when the second derivative dx squared, and I substitute the value of x equals root 3, and when I work this out, this will give us a gradient value of 13.856. So as the second derivative is greater than 0, it's going to be a minimum point at that coordinate of root 3 0. And then if I then do the same, so when dy, the second derivative is, and I substitute minus root 3, that's going to equal, again just type that into my calculator, I get minus 13.58 or minus 13.856. So as the second derivative is less than 0, it's going to be a maximum point at minus root 3 0. And there we go. Question 8d, it says write down the equation of the line which is a tangent to the curve in those two places. Now if I do a little sketch of what the graph actually looks like, it looks something, actually that's pretty poor, so let me do that again. So it looks something like this, where this point here is minus root 3 and this point here is positive root 3. Now the tangent for both of those is this line here, which I probably shouldn't do in pink, over a current line. So it's this blue line here, and the equation of that tangent is y equals 0. So then moving on to question 9, it says integers m and n are both odd numbers. Prove that m squared plus n squared is a multiple of 2 but not a multiple of 4. Now for this, it's not mentioning that m and n are consecutive odd numbers. All we know is that they are odd numbers. So what we need to do is find an expression for m and n that are different odd numbers. So we can then say that m is going to be something times 2 plus 1, and n is going to be 2 times something else plus 1. So they're the two expressions that I'm picking for my two odd numbers, and those two will be odd for all values of a and all values of b. Again, I've only just picked A and B just for anything. You could pick absolutely any other two letters. I strongly wouldn't recommend going for M and N, but it is what it is. So then from this, what we can then do is then work out what m squared plus n squared is going to look like. So then taking this as 2a plus 1 and n as 2b plus 1, what we end up with is 2a plus 1 squared plus 2b plus 1 squared. Then if I expand the brackets out, I get 4a squared plus 4a plus 1 plus 4b squared plus 4b plus 1. Now from this, what I can then do is neaten all of this up. So I get 4a squared plus 4a plus 4b squared plus 4b plus 2. So from this, I can factorize this by taking a 2 out. So I end up with 2a squared plus 2a plus 2b squared plus 2b plus 1. So therefore, as 2 is a factor, it will therefore be a multiple of 2. Well, when I say therefore be, basically I mean m squared plus n squared will be a multiple of 2. Now, in order for it to be a multiple of 4, and it's worth stating this, is, let me just find a pen that's actually going to come out. So let's go for this one here. So if m plus n squared is a multiple of 4, then 2a squared plus 2a plus 2b squared plus 2b plus 1 must be a factor of 2, because 2 times 2 equals 4. Now the problem with this is that this isn't going to be a factor of 2, so it is not a factor of 2, as you are adding 1 to what will be. Now 2a squared is a factor of 2, 2a is a factor of 2, 2b squared has a factor of 2, and 2b has a factor of 2. So therefore all of this bit here will be a factor of 2, but when you're adding 1, it's not. So it's not going to be a multiple of 2. So adding 1 to a factor of 2, so therefore m squared plus n squared is not a multiple of 4. So something along those lines would be absolutely fine. Then moving on to our last question on this section 8, it says curve C has the equation of y equals root 2 over x squared. Find the equation of the tangent at C at point 2 root 2 over 4. So for this particular question, let's first of all start by rewriting the original equation. So that's going to be root 2 x to the power of minus 2. I can then work out what dy over dx is, which is going to be minus 2 root 2 x to the power of minus 3, or I can write this as minus 2 root 2 over x cubed, so whichever of those you prefer. From this I can then work out the gradient at 2 root 2 over 4, and I can do that by substituting the value of x equals 2 into dy dx, and this would equal minus root 2 over 4. And then from this, we then know that m equals minus root 2 over 4. We've got a coordinate of 2 root 2 over 4. So then using y minus y1 equals mx minus x1, the equation of the tangent is going to equal y minus root 2 over 4 equals minus root 2 over 4x minus 2. Now you could leave your answer like that, Or you could write in the form of y equals mx plus c, in which it would be y equals minus 2 over root 4x plus 3 root 2 over 4. Or you could write your answer as 4y equals 3 root 2 minus x over 2. So any of those answers would be absolutely fine for the equation of the tangent. And this would equal minus root 2 over 4. And then from this, we then know that m equals minus root 2 over 4. We've got our coordinate of 2 root 2 over 4. So then using y minus y1 equals mx minus x1, the equation of the tangent is going to equal y minus root 2 over 4 equals minus root 2 over 4x minus 2. Now you could leave your answer like that, or you could write in the form of y equals mx plus c, in which it would be y equals minus 2 over root 4x plus 3 root 2 over 4. Or you could write your answer as 4y equals 3 root 2 minus x over 2. So any of those answers would be absolutely fine for the equation of the tangent. For 10b, it says show that the tangent to c at the point 2 root 2 over 4 is also a normal to the curve at a different point. So looking at this particular question, well, let's first of all start by writing the equation of the tangent that I found. So the equation of the tangent is y equals, and I'm going to go for, oh, I don't know what's up in there. So I'm going to go for writing the equation of the tangent in the form of y equals, so it's 3 root 2 over 4 minus x root 2 over 4. I also know that the curve C is y equals root 2 over x squared. So these are the two equations that I'm working with. Now the intersection of those 2 points, as they're both equal to y, so the intersection point is going to be 3 root 2 over 4 minus x root 2 over 4 equals root 2 over x squared. Now what I want to do is I just need to make this a little bit easier because I need to solve this for x. So again, I can write this as 3 root 2 minus x root 2 over 4 equals root 2 over x squared. I can then cross multiply, in which I get 3x squared root 2 minus x cubed root 2 equals 4 root 2. And then I can divide everything by root 2. So that then becomes 3x squared minus x cubed equals 4. And then I can then rearrange this to try and solve it. So I get x cubed minus 3x squared plus 4 equals 0. And then from this, what I can then do is factorize this or go on and solve it. So it's entirely up to you. But if I factorized it, and just to save a bit of time, I get x minus 2 squared and then x plus 1 equals 0. And all I've done there is factorized. Then from this, I could then go on and solve. So I've got x equals 2 or minus 1. Now this one is already known, so I know this. So this is my new point. So then from this, so this is my new intersection point. So then from this, what I can then do is, if I get a different colour pen, so from that I can then do dy over dx. I want to work out the tangent at that particular point when x equals minus 1, and that's going to equal minus 2 root 2 over minus 1 cubed, which equals 2 root 2. So this value here is the gradient of the tangent at the new intersection point. So then from this, if I then combine the gradient of the line that I was given, and this new intersection point. So if I then recall 2 root 2, which is the gradient of the new intersection point, and I multiplied that by minus root 2 over 4, and again this is the gradient of the tangent at C, and if I type that all into my calculator I get an answer of -1. So therefore that this is perpendicular to the curve, so it's a normal. And there we go.